Hello and welcome to today's episode of One Man and His Whiteboard. Today we continue in our conversation on IP subnets, part 3, non-byte boundaries. So what we want to talk about today is the concept where you may have to do subnets, but they don't fall on a byte boundary. So up until now we've talked about using the second or the third byte to use subnetting. And this is easy. It's always the simplest and always the best way to do it if you can. But sometimes we may have a situation where we don't have the luxury of a byte boundary. So let's say we wanted to take a look at 10.1.something. And in this situation, we're going to be using the third byte as a subnet field. So obviously the second byte is already a subnet field, but we can also include the third byte, but not all of it. It's as if we're going to chop it in half, for example. So our mask is going to be the left 4 bits are going to be 1s, and the right 4 bits are going to be 0s. Now that value is 240 in decimal. There's a couple of things you need to be aware of when you do this. Basically, you all know the 255 is 1 1 1 1 1 1 1 1. 8 ones. Well, what if we wanted to use a mask of less than 8 ones? Well, I've just shown you the mask for 4 ones and 4 zeros. I just told you that that's 240 in decimal. Well, what about using 1 1 1 1 and then 1 1 1? Okay, and then 1 1 1 1 and then 1 1, and of course 1 1 1 1 with just a 1, and all other numbers are 0. If it's not a 1, the only other option we have is of course a 0. Well, this number here is 254. This number here is 252. And this number here is 248. Let's continue our progression. 1 1 1 1 1, and then of course good old-fashioned 1. All numbers that aren't 1s, I'll draw them in just to be exact. Quite often you might see that they're not actually used at all, they're just implied, but I'll draw them in to be more exacting. Those of you who are watching this on video, this is why fast forward was invented, okay? Okay, so I'm going to clear that up a little bit. It's not very clear. That's 240. That's 224. That's 192. You get to know these numbers after a while. And of course, that's 128. Now remember, that's bit 1. That's the bit for 2. That's the bit for 4. That's the bit for 8. That's the bit for 16. That's the bit for 32. That's the bit for 64. And that's the bit for 128. So when you want to work out what 11110000 is, it's going to be 128 plus 64 plus 32 plus 16, 240. So now that we understand that this is 240, our mask is obviously going to be 255.255.240.0. Or you can write down there's 8 bits, 8 bits, 4 bits of networking, 0 bits of networking. That equates to a /20. Is how we write it down using the /20, the slash format. So looking a little deeper into this, what are the networks going to be? Well, it's actually quite simple once you think about it. We've said that we're using the following bits: 1, 1, 1, 1, 0, 0, 0, 0. So this is the host portion, and this is the subnet portion. So these are all little subnet bits. We'll draw them with little ends. And these are all, little host bits. I'm going to use technology, and I'm going to put a line down the middle, just like that, to separate the network from the host. So how do we work out what's going on here? Well, looking up here, this 4th bit from the left is the 16 bit. The bit that represents the number 16. So the possible networks we're going to have, we have to fill in all these numbers. Now remember, I showed you a little trick before, that on the rightmost column, you alternate the 0 and 1s once. In the next column, I'm going to move this over a little bit, try and see if I can line them up in my squares. It makes it just a little bit easier for formatting. Okay. In the second column over, if you want to do a perfect count in binary, you alternate every 2. So it's as if you alternate 0 and 1 once, alternate every 2, alternate every 4, alternate every 8, and so on. And this gives you a perfect count in binary. Then you alternate every 4. Then you alternate every 8. I'm going to shortcut this now. If you want to write all 16 down, it's okay. But what if you want to calculate 32 or 64 different numbers? You're going to alternate 0 and 1 once, then 0 and 1 twice, 0 and 1 4 times, 0 and 1 8 times. Then the next column over is going to be 0 and 1 32 times. Then the next one is 64 zeros and 64 ones. Well, it gets a bit boring. The ones in the middle you can sort of assume. How about just zipping down to the end? Well, you just do the opposite. You do a 1 and a 0, alternate the 1s and the 0s, but you start off with a 1. Then you alternate 2 1s, but start off with a 1. What you'll find out is, not only have I given you a shortcut on how to count in binary, but I've now given you a shorter shortcut on how to write down a lot of numbers in binary. So obviously these are going to go on now, and basically I'm stopping there just for time's sake. So we infer all the other numbers in the middle there we don't care about. Well, whenever you do this little trick with networking, you have to assume that all of these in the host field are 0. Okay? So every single one of these numbers are going to be zeros in the host field. So you only have to pay attention to these values over here, because these are always going to be 0. So the first network we have available is 0. Then you have the next available network where the 1 is. Remember, this is in the 16 column, so that's going to be 16. The next one is going to be 32. The next one is going to be 48. Now, I'm actually going to straighten this up because I seem to have got a little off center here. That looks a little better. There you go. Well, they aren't quite lined up, but I trust you can get the idea of what I'm talking about. Hey, little light bulb just went off. Phil, are you saying that the networks all go up in 16s? Yes, I am. And if you used a 1110000, 3 ones and 5 zeros, anybody surprised if all the networks go up in 32s? If I use 6 ones with 2 zeros as my network mask, hey, all the networks go up in 4. The first network's going to be 0. Second network's going to be 4. Now remember the rule about the zeros and the ones. We don't like any field having all zeros in it. So we tend to not use the 0 if we can help it. There is a little bit of a trick here in that we are actually using 8 plus 4, 12 bits of subnetting. So we have 8 bits of networking. There's the subnet. 12 bits of subnetting. 8 bits for hosts. Subnet. 12 bits for subnetting. So the 0 would actually be allowed here because you can't have all 12 bits being 0. But in a situation where you're doing something similar to what I'm showing you here, if this was a 172.16 network, we would only be using 4 bits of subnetting. So you can't use subnet 0. So as a general rule, we don't allow that one. And of course, the big number down here is going to be 240, right? Well, we've already explained that 240 is the subnet mask. So you tend to lose 1 at the top and you lose 1 at the bottom. Now, I must warn you all, be careful here, because I've used 10.1, we actually have 12 bits of subnetting, right? So that rule doesn't apply as is. It's just you can't have all the network bits as 0, you can't have all the host bits of 0, and you can't have all the subnet bits as 0, or 1 in each case. So it's best to just avoid them and you won't be confused. If you come back and say, well, actually, Phil, I've got to design a network where I need every single host and network that I have, my response would be, by that time, you're such an advanced networker or designer, you should be able to adjust and understand that there are 12 bits of subnetting, so you wouldn't have a problem. We understand the default masks. Remember, there's another one here of all zeros. So a mask can be 8 zeros, 8 ones, or any combination of zeros and ones between that range. And there's another rule as well you have to be aware of. You'll learn it in more detail when we come on to the design section, design in subnets. There's a general rule with subnetting that ones must be contiguous and they must start from the left in the network mask. So you aren't allowed to have a subnet mask of 255.7 because that would give you 3 ones on the right. You aren't allowed to have a subnet mask, so that's going to be all zeros, 111. You aren't allowed to have a subnet mask of 255.83. I wish I'd picked an easier number. That's going to be 0, 128, 164, and 0, 32s. We'll throw 16 in there to make it 80, and then we'll have 0, 0, 1, 1. So that's not allowed as a network mask, and that's not allowed as a network mask. Network masks have to be contiguous, which means all joined together, so you can't split the network mask numbers up, and they have to start from the left. So you can only have a network mask that's 0, 128, 192, blah, 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 up to 255. You can't have a network mask of 1, for example, because that would be a 1 starting on the right-hand side, not starting on the left. So all networking bits must be left justified, start from the left, and they must be contiguous. They must be grouped together. That's a little rule you learn about a little bit more details on later on the IP subnetting section that talks about designing subnets. It's generally a good idea to never allow all zeros and all ones in any field, the network field, subnet field, or the host field. Now, when you get onto advanced networking, there are tricks you can do in service providers where you need every single last possible bit manipulation. There are things you can do to adjust those rules. In general, basic networking, you can't have all zeros or all ones in the host field, all zeros and all ones in the subnet field, and all zeros and all ones in the network field. Don't do that, and your networking career will be very successful. That's it for today's webinar. We'll see you next time.